Welcome to Geometry Lesson 5.3, Inequalities. This is a review of inequalities that we've learned from Algebra 1 and from earlier in our text. The properties of inequality are very similar to the properties of equality. Instead of equal signs, your properties are demonstrated using less than or greater than or less than or equal to or greater than or equal to. So with addition, you would say A plus C is greater than or less than B plus D. In equality, it would have had an equal sign here. The only property that's new in this table is trichotomy. In trichotomy, which is a property we use quite frequently for proofs, A equals B. Or I should say, if A equals B, then A will be less than B or A will be greater than B. Now this is for inequalities only. So A will be less than B or A will be greater than B, or as we've already learned, A will equal B. The comparison property comes from that trichotomy property. For any real numbers a, b, and c, if a equals b plus c and c is greater than 0, then a is greater than b. To demonstrate that, for any real numbers, numbers 5, 3, and 2, if 5 equals 3 plus 2 and 2 is greater than 0, then 5 will be greater than 3. You'll find that this is intuitive. This is something you already understand. Let's take a look at example 1. We'll use greater than, less than, or equal to complete each conclusion. Then name the property used to reach that conclusion. So, if the measure of angle XYZ equals the measure of angle 1 plus the measure of angle 2, then the measure of angle XYZ will be what in comparison with the measure of angle 2? So we're talking about this angle here, XYZ, which also is two angles, numbers 1 and number 2. We know that these two angles add up to equal the angle Y, but they're asking you to compare this angle Y to the portion of the measure of angle 2. So this whole angle would have to be greater than the measure of angle 2. So it'll be greater than. Let's move on and take a look at example B. If XP is less than XY, so XP is this piece right here, and it's going to be less than XY, and ZP is less than ZY, then XP plus ZP would have to be what in comparison to XY and ZY added together. This is also comparing, but we're actually using addition property of inequality to do the comparison. So in this one, we know that these are smaller pieces added together compared to larger pieces added together. So obviously, XP plus ZP will be less than, XY plus ZY. The exterior angle inequality theorem, theorem 5.3.1. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Given triangle ABC, we can see that here, ABC, with exterior angle 1. The exterior angle theorem implies that the measure of angle 1, right here, equals the measure of its remote interior angles, B plus C. Both the measure of angle B is greater than 0, and the measure of angle C must be greater than 0. The comparison property indicates that the measure of angle 1 is greater than the measure of angle B, and the measure of angle 1 will be greater than the measure of angle C. Now, how do I know that both the measure of angle B is greater than 0 and the measure of angle C is greater than 0? When working with measurements or distances on real figures, your numerical values will be greater than 0. We have the greater angle theorem, theorem 5.3.2. If two sides of a triangle are not congruent, the larger angle is opposite the longer side. This is very important. You're going to use this over and over again. So, the reason they're stating if two sides of a triangle are not congruent is this will not work the same for isosceles or equilateral triangles. So the larger angle is opposite the longer side. In this triangle, it says if side BC is greater than AB, then the measure of angle A will be greater than the measure of angle C. So the longer side will be opposite the larger angle. Let's take a look at example 2. List the angles of the triangles in order from smallest to largest. The smallest angle is opposite the shortest side, and the largest angle is opposite the largest side. Let me say that again. The smallest angle is opposite the shortest side, and the largest angle is opposite the largest side. So, our shortest side here will be MN. So, the angle opposite it is angle L. So that will be our smallest angle. Our next smallest side is LM, and its angle opposite it is angle N. So L and N, and our largest side is 14. The angle opposite LN is angle M. This brings us to another theorem, the longest side theorem, theorem 5.3.3. If two angles of a triangle are not congruent, the longer side is opposite the largest angle. So the longer side is opposite the largest angle. Let's go back up here and see what this said again. This was greater angle theorem. So 5.3.2 is talking about the angle, and 5.3.3 is referring to the side. So when you're doing these problems and you have to reference which theorem it went with, remember that one is for a side and one is for the angle. So in this instance, we're talking about the longer side will be opposite the largest angle. So if the measure of angle A is greater than the measure of angle C, the side opposite angle A will be the longer side. Theorems 5.3.4 and 5.3.5 apply the longer side theorem, and we get two more theorems. In theorem 5.3.4, the hypotenuse is the longest side in a right triangle. This is some information that you already know. In 5.3.5, the shortest segment from a point to a line is a perpendicular segment. We won't use this very often, but it is a byproduct of the theorem. So the homework for lesson 5.3 is numbers 1 through 18 and number 25. An example for how to do these problems. Number 3, list the side lengths of each triangle from shortest to longest. Remember, the shortest side is opposite the smallest angle. In these problems, they'll be very easy, but you'll make mistakes because you won't read shortest to longest or longest to shortest. Be very careful there. So number 3 says list the shortest side. List the side lengths from shortest to longest. So that means we need to look at our angles. Find the smallest angle, which is angle R, and the side opposite it is QP. And then our next angle is angle P, so the side opposite angle P is QR. And then our last answer would be the side opposite the large angle of 95 degrees, which would be PR. Number 11. List the angles of each triangle from smallest to largest. Remember, the smallest angle is opposite the shortest side. So once again, we're going smallest to largest. And let's take a look. We have a variable of y. We have a side that is y minus 10 and a side that's y minus 20. So your shortest side will be y minus 10 because it's less than y. Then our second shortest side will be y, and the longest side will be y plus 20. Number 17. Compare the given measures. Your answer. Well, let's take a look at this. The measure of angle 2 is what in comparison with the measure of angle ABC? So ABC is part of this larger angle of the triangle, and the measure of angle 2 is one piece of that larger angle. So the measure of angle 2 would have to be less than the measure of angle ABC. And what did we do to find this? Which theorem? It's the comparison theorem. Hope this helps. If you need any assistance, please be sure to contact me. God bless.